Hello friends, welcome to Siddha.com. Now in this video we will apply the mole concept on the molecular substances. In our last video we learned what the mole is, and for all those people who have not seen that video, I would strongly suggest you people to go first over to that part first of the video. Just learn what the one mole is and then come to this second part of this video lecture. For the molecular substances like water, sulfur dioxide, the molecular mass is actually the sum of the atomic masses in the molecule. So like here we got the H2O, it contains 2 hydrogen atoms and the atomic weight of hydrogen is 1. So therefore for the 2 hydrogen atoms it will be 2 into 1, plus it is oxygen 1 and the atomic mass of the oxygen is 16. So therefore total it will be the 18. Similarly for the sulfur, the molecular mass will be sulfur, its atomic number is 16 but the atomic mass is 32, and we got 2 oxygen atoms, and for 1 oxygen atom the atomic mass is 16. So therefore the total weight will be the 64. So 64 is the molecular mass of the sulfur dioxide. And in this one, CH4O, the molecule contains 1 carbon and the atomic mass of the carbon is 12. For 4 hydrogen atoms it will be 4 into 1 plus 16 for the oxygen. So here the total mass is 32. In our last video we have learned how to find the number of the particles, number of the moles present in the given weight of a substance. There we learned that the number of the moles of an element will be equal to the weight of the substance, weight of the element expressed in the grams, divided by the atomic weight, right? Atomic weight. And we learned there, when you express the atomic weight of an element in grams, that is the molar mass of the element. Like we have a carbon, atomic number is 6, atomic mass is 12. So when you express the atomic number of the carbon in grams, that is equal to the 1 mole of a substance. That is equal to the 1 mole of carbon. That means it contains 6.022 times 10 power 23 carbon atoms. All these things we have learned. I strongly suggest to you people to first go over to that video if you have not seen that. So same concept we apply here. When we take a molecule, for the molecules, when we express the molecular mass in grams, like for the water, the molecular mass of water is 18, and when I express the molecular mass of the water in grams, it is equal to the 1 mole of the water. So therefore 18 grams of the water will be equal to 1 mole of water, 1 mole H2O. That means it contains 6.022 times 10 power 23 H2O molecules. Similarly for the sulfur dioxide, 64 grams of sulfur dioxide is equal to 1 mole of sulfur dioxide, 1 mole of SO2, which is equal to 6.022 times 10 power 23 sulfur dioxide molecules. Hence we got the conclusion here that when you express the molecular mass in grams, that is the molar mass of the substance, right? So when you take the molecular mass of a substance in grams, that will be the molar mass of that substance. Hence we can also use the same formula here. Simply we will replace the atomic weight by the molecular weight, right? So therefore the number of the moles of the substance will be equal to the weight of the substance in grams divided by the molecular weight or the molecular mass, right? For example, if you want to calculate the number of the moles of water present in 24 grams of water. So the number of moles of water in 24 grams will be 24, the weight of the substance, divided by the 18, which is actually the molecular weight, right, of the water. So it is weight of the substance here is 24 and the molecular weight is 18, so it is 24 by 18. So it will be 1.333 moles. Now let's take some other examples. Calculate the number of molecules present in 2.5 grams of water. So water here, H2O, its molecular mass is 18. So therefore the molar mass is 18 grams. Hence, N we know is the number of moles. That will be equal to the weight of the substance expressed in the grams divided by the molecular weight of the substance. So that is, from 2.55 grams we can first calculate the number of moles. So this will be 2.5, weight is 2.5 divided by 18. That will give us the number of moles, and from the number of moles we can calculate the number of particles, number of molecules there, right? So it will be 2.5 divided by the 18, which is equal to 0.13888, right? Or roughly I can take it 0.139 moles of water. Okay, this is the number of moles of the water, and the number of molecules will be then number of molecules in 0.139 moles is equal to times the Avogadro number, which is 0.139 times 6.022 times 10 power 23 H2O molecules, right? So times it will be 0.836 times 10 power 23 molecules, or I can say it is 8.36 times 10 power 22 molecules, right? H2O molecules. We can also find the number of oxygen and the number of hydrogen atoms, right? See, if you want to calculate the number of oxygen atoms in the same amount of the water, 2.5 grams, you can calculate the number of oxygen atoms also. In the H2O molecule, it contains one oxygen atom and two hydrogen atoms. So the number of oxygen atoms is exactly the same, the number of molecules. So therefore the number of oxygen atoms will be 8.36 times 10 power 23 atoms, right? The same number of molecules now. But the number of hydrogen atoms will be 2 times the number of water molecules, right? It is 2 times the number of H2O molecules. Why? Because in one molecule of water there are 2 hydrogen atoms, so therefore the number of hydrogen atoms will be 2 times 8.36 times 10 power 22 atoms. Fine, so let's take another example. How many moles of methane are present in 6.0 grams of methane? So we got the weight, we need to find the number of moles. Again, we will use the same formula. N is the weight of the substance divided by the molecular weight, right? So that will be equal to 6.0 divided by the molecular weight of the methane is 16, because the methane is carbon 12 and 4 times 1, which is equal to 16. So it is the 16 is the molecular weight of methane. So therefore the number of moles will be, it is 6 divided by 16, which is equal to 0.375 moles. We can also find the number of carbon atoms and the number of hydrogen atoms, right, in this given weight of the methane, right? So therefore the number of carbon atoms will be, in the 6 grams of the CH4, what will be the number of carbon atoms? The same now. Why? Because you got the CH4 and 1 molecule of methane contains 1 carbon atom, so number of carbon atoms is equal to the number of molecules, right? So you can say it is, the number of carbon atoms will be 0.375 times the Avogadro number, because we need to first find the number of molecules. So we will first change the number of moles into number of molecules. So I am going to multiply by the Avogadro number. So it is 0.375 times 6.022 into 10 power 23, right? So this is 2.258 times 10 power 23 carbon atoms, right? Okay, and this will be the number of methane molecules also, but the number of hydrogen atoms will be, we got the 0.375 moles of the methane, but in one molecule there are 4 hydrogen atoms. So therefore I'll multiply 4 times the number of moles, 0.375, this is the number of moles, and now it will give me the total number of moles of hydrogen. But if I want to find the number of hydrogen atoms, I have to multiply by the Avogadro number, right? So it will be then it will be then 4 into 0.375, which is 1.5 into 6.022 times 10 power 23. That will be equal to 9.033 times 10 power 23 hydrogen atoms. Now let's take another example. How many molecules of glucose are present in 60 grams of the glucose? We know the glucose, the formula of the glucose is C6H12O6, and therefore what will be the molecular weight of glucose? It is 6 times 12 plus 12 times 1 plus 6 times 16, right? So it is 180. This is the molecular mass, right? So now we can easily find the number of moles first, and from the number of moles we can find the number of molecules. And the number of moles of the glucose will be equal to weight of the substance expressed in the grams divided by the molecular weight of the substance. The weight here is 60 grams divided by the molecular weight is 180. So it is 1 by 3 moles, which is 0.333 moles of glucose. So therefore the number of molecules will be number of molecules of glucose will be equal to 0.333, and this is number of moles times the Avogadro number, which is 0.333 times 6.022 into 10 power 23 will be equal to 2.005 times 10 power 23 molecules. And now we got the number of molecules, we can even find the number of carbon atoms, number of hydrogen atoms, and number of oxygen atoms. So let's find the number of carbon atoms also. Number of carbon atoms, it will be 6 times, right? Because in one molecule there are 6 glucose molecules. In one glucose molecule there are 6 carbon atoms. So it is 6 times the number of molecules, 2.005 times 10 power 23. Similarly, the number of hydrogen atoms will be 12 times 2.005 into 10 power 23. And the number of oxygen atoms will be 6 into 2.005 times 10 power 23 atoms. Hope you got the concept. Thanks for watching the video. Bye for now.